All right, moving on. Looking at problem number 4 here, it says points A and B are on opposite sides of a lake. A point C is 99.8 meters away from A. The measure of angle A is 78.8 degrees, and the measure of angle C is determined to be 21.1 degrees. Find the distance between points A and B to the nearest meter. So let's draw a picture of what they've given us. So again, let's draw in this lake. Put it up here. We got our lake here. Let that be our lake. It says points A and B are on opposite sides of the lake. Point C is 99.8 meters from A, and C is determined to have an angle of 21.1 degrees. A is determined to have an angle of 78.8 degrees. But let's go ahead and put those 2 points here. And we'll keep in mind A's got a 78.8 degree angle. But A and C on opposite sides. There's A and there's B on opposite sides. And it says point C is 99.8 meters away from A. So let's put point C in here. So again, as we're looking at it, we can go ahead and connect these. And of course, we have our 3 vertices to a triangle. And again, this is 99.8 meters away from A. And we know the angle measurements, this is 78.8 degrees. We also know angle C is 21.1 degrees. All right. So we'll go ahead and label that in there. So we're given those measurements. So again, just getting a picture of what we have in front of us. All right. So as we do that, now as we look at our triangle, right, we've labeled everything they're giving us now. With that said, what type of triangle do we have? We got an angle, a side, and an angle. So we got an angle, side, angle triangle in front of us. So I'm going to go ahead and make that note. So we're needing to find any of these missing parts. We can do so using the law of sines, right? We know angle, side, angle, 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 side, 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 angle. Those are law of sines. We know side, 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 angle, side. Those are law of cosines. Well, the question was, it said find the distance between points A and B. So I'm going to find that distance here. So in our drawing, if you want, we can label that. Right, here's our unknown. Let's find this side here. So C, right, would equal. C equals distance between points A and B. All right, so as we're going to look at finding side C, let's use our law of sines. So C over the sine of angle C equal. Now we are going to need to finish out information. We were given side B, right? We were given this side opposite of angle B. So we can go ahead and use that ratio, right, to help us in solving. Now let's go ahead and get angle B. Now we know angle B. We know again how to find the third angle. 180 minus the sum of the 2 that we're given. So 78.8. All right, let's go ahead and draw that in here. 8.8 degrees plus 21.1 degrees, which is equal to what? 180 minus 99.9. All right, let's go on a show of work. 9 degrees, which is equal to what? 80.1 degrees. So B, we've now got it 80.1 degrees. So we draw in there for angle B. So back to our law. So that implies C over the sine of angle C. So C over the sine of 21.1 degrees, angle C was given to us, equal side B, which was given to us, 99.8 meters in length, divided by the sine of angle B, which we just found, which is 80.1 degrees. So we set up our proportion, which we have one unknown. So to find C, all we got to do is solve for it. Let's do our algebra together. Let's go ahead and isolate. Let's go ahead and get rid of that coefficient of 1 over sine of 21.1. And we can do that by multiplying both sides by the sine of 21.1, so they divide out. As we have that, we now have C equal to 99.8 times the sine of 21.1 degrees divided by the sine of 80.1 degrees. And now you can go type that into your calculator, right? And you do that, you get approximately 36.5, which is around 37 meters, right? Remember it said round to the nearest meter. So 37 meters, there's a distance, right, between points A and B. So again, we end up solving the oblique triangle using the law of sines, getting us to that unknown, the distance between points A and B. All right, moving on, let's go to example 5. And number 5 says graph the points on the given polar grid. So we got 2 points here, 2 and negative pi 4. So again, remember polar coordinates. Polar coordinates, again, we assign location by distance and rotation, angle. So we have a radial coordinate, we have an angular coordinate. So again, we talk about the points R and theta. So R is again the radial, and theta is the angle. Now with that said, here's R and here's theta. Our first step, all right, let's go ahead and look at the pole. The pole is right here at the origin. So again, that's the pole. And here's the polar axis. So the polar axis is right here, the positive side of the x-axis. All right, with that said, we need to go ahead and rotate negative pi over 4. So negative pi over 4 radians, right, is a rotation of negative 45 degrees, right? Right here in the middle of quad 4. That'd be a rotation there of negative 45 degrees, negative pi over 4. So there's theta. So given theta, we're here marking it. So negative pi over 4. Now 2 means we're going to a distance, a radial distance of 2 units. So here's 2 units out. So we're going to plot our point. I'll do it here in red, right? We got our point right here. There's 2 units from the pole. Again, a distance of 2 radians. So we're going to plot that. So there's that point, 2, negative pi over 4. So again, locating that point's in quad 4. All right, how about the other one? The other one we got 750 degree rotation. Now with that being a positive rotation, right, we're looking at going counterclockwise, right, with positive rotations. Now where is 750 degrees? So we go counterclockwise, right, there's 360, a full circle. As we go in here and we rotate again another 360, there's 720 degrees. So 750 degrees, right, be 30 degrees into quadrant 1. So right here is 750 degrees rotation. It's a quadrant 1 angle. So 2 complete revolutions, 720, and then another 30 degrees. So there's our 750 degree rotation. Now our radian measure, right, we got a radius of negative 3. So that means with a negative going the opposite direction. So we're going to the 30 degree mark in this quadrant here in 3. So here's our 30 degree mark here. So negative 1, right, negative 2, and there's negative 3. So right here is our point. So we're plotting that point. Here's negative 3. Here's the polar coordinates. Negative 3, 750 degrees. Just remember you go the opposite direction, the 30 degree mark of quadrant 3. So we'll make note of that. Again, we can even put that in here. So that's a 30 degree between, and this is our 30 degree mark, our reference angle here in this quadrant. So again, you see plot polar coordinates. We go the rotation, use the angle, and then we go the radians. Now let's do some conversions. We move on. Looking at problem number 6, convert to polar coordinates. Give the exact coordinate, express the answer in both degrees and radians. Use the smallest possible positive angle and show your work. Well, let's look at this first one. Example number 6, they give us the ordered pair of 0, negative 1. Well, let's plot that point. It won't take us long to convert this one. All right, so we look at this one. Let's go ahead and draw in our x and y axis. All right. as we plot the point 0, -1 down here on the y-axis. Now we want to convert this over. So there's x and y, rectangular coordinates. So we want to convert it to r and theta. We want polar coordinates. So with that said, let's go ahead and map that with polar coordinates. So here's the pole, right? Here's the polar axis. It says use the smallest possible positive angle. So we're going to rotate from the pole, right, all the way over here to this point. There's theta. So that's what? Theta is 270 degrees, right? Or 3 pi over 2 radians. So we'll do it in radians. And it says express in both degrees and radians. So there's theta. Now radius, well, what's the distance? So as we look at the distance from the pole to that point, we went down 1 unit. The distance is 1. So there's our radius. There's r, right? 1. So we've got our coordinates, right? Just looking at it, we know this is what? This is the polar coordinates of 1, 270 degrees, or in radians, 1, 3 pi over 2 in radians. All right, so again, that was an easy one to convert just based off the y-intercept point. Given us an intercept, we can easily, all right, see it without any conversion formulas. Now let's take a look at our next example. So we look at problem number 7. And problem number 7, all right, we're given 6 squareds of 3 and 6. Let's go ahead and look at that here on our xy axis. Plot that point. So right 6 squareds of 3, right, and then up 6 units. Gonna put us up here, right, in quad 1. And that order pair of 6 squareds of 3, 6. So as we look at it, let's go ahead and talk about it in terms of polar coordinates. So we want the distance, there's a radius, and we want theta. So that's what we're looking for in this problem. Now what we will have in front of us, we've got x and y. So we know the horizontal and vertical distance. We've gone right 6 squareds, 3 units. We've gone up 6, right? That's x, and that's y. So we've got a right triangle. So if we're trying to convert, right, if we want to know what r and theta are, right, we want to find r and theta. So with that said, let's get r. So r is the hypotenuse. So let's use the Pythagorean theorem, right? Pythagorean theorem will allow us to find the radius. R squared equal the sum of squares of the other two sides, the two legs, 6 squareds of 3 squared plus 6 squared. All right, and as we solve that, we'll go ahead and take the square root of both sides. Right, we'll get our radius. So our radius, r, is equal to the square root of 6 squareds of 3 squared, right, plus 6 squared. And let's go ahead and simplify that. Now 6 squareds of 3 squared, 6 squared is 36 times 3 plus 36. And 36 times 3, that's 108. 108 plus 36, which is what? 144. So we end up with 144, and that's a perfect square. That's 12. There's our radius. We converted it. Now radius is always calculated. So based off this definition, right, radius is always equal to the square root of x squared plus y squared. Right, there's our formula conversion. You can see it proved here. Right, there's r equal to squared x squared with y squared. Pythagorean theorem shows us that. Now let's find theta. So how are we going to get theta in this problem? So to find theta, well, let's use another right triangle trig definition. Let's use tangent. We all know that the tangent of theta equals opposite over adjacent. It equals y over x. So again, as I'm looking at my definitions, right, tangent theta is y over x, y coordinate, and their x coordinate. Tan theta is y over x. I'm going to write that up here. We understand that definition back from right triangles, right? We proved again circles and rotations, right? Our opposite and adjacent side is our y coordinate, x coordinate with that picture. So as we simplify that, of course, that's the tan of theta equal to what? 1 over the square root of 3. And as we rationalize, we end up getting what? Square root of 3 over 3. So that implies tan of theta equals square root of 3 over 3. And if you remember, now that's one of my special angles. Now you could, if you want, you could use your inverse feature, right? Theta is equal to tan inverse of square root of 3 over 3. And that'll give you 30 degrees. All right, but we're looking at it. I know it, again, a special angle. I know tan of 30. So if you're looking back at the unit circle, right, to help you, 30 degrees, a y and x coordinate, we got 1/2 square root of 3 halves. 1/2 of square root of 3 halves is square root of 3 over 3. So we should know that. That's one of our special angles. But there's theta. So we got r and we've got theta. So what are our polar coordinates? So now we found our answer. So our polar coordinates, we can put it up here with it. We've got polar coordinates of radius 12, theta 30 degrees, right? Or, like I said, if you want to put it in radians, or pi over 6. 12 pi over 6 radians. Either one, right? Wanted it in radians or degrees. You can easily give that. So again, that's conversions. So looking at converting from rectangular to polar coordinates. So again, we've got definitions, right? We got a Pythagorean theorem that produced our radius, and we got the tangent function, allowed us to get to theta.